Every night before we go to bed, we brush our teeth, and we usually use toothpaste. Well, we should. Have you ever wondered why toothpaste comes out when we squeeze the tube? Well, let me explain it to you. But before we explain it, let me first introduce you to a person called Blaise Pascal. He is a French mathematician, physicist, and inventor. The Pascal principle was first stated in 1652 by Blaise Pascal. It was said that in 1646, Pascal did a barrel experiment. He had a barrel full of water. This is my drawing of a barrel. And inserted a long vertical tube into the barrel, in which water was poured into the tube, which increased the water pressure within the barrel, causing the barrel to burst. Although the experiment was never mentioned in Pascal's preserved works, the experiment remained associated with Pascal in many elementary physics textbooks. And this is my drawing of Blaise Pascal with water, and he's pouring it down the tube into the barrel, and it's bursting. The barrel experiment tells us that a change in the pressure applied to an enclosed, incompressible fluid is transmitted undiminished to every portion of the fluid, to the walls of its container. Or in simpler terms, if pressure is applied on an enclosed space, the pressure at every point of the enclosed space will increase. This is the Pascal principle. So now you know why every time you squeeze a toothpaste to Pascal's principle is in action. Whether you are holding the toothpaste tube vertically or horizontally, when you squeeze the tube, you increase the pressure in the tube, causing the pressure to push the toothpaste out equally. The blob of toothpaste in the neck of the tube is subject to this pressure. And now let's move on to our formula. So, using this formula, we can show Pascal's principle. This is pressure, this is force, and this is area. This is in a unit of Newton, and this is in a unit of meters squared. Now, let's see an example. So here I have, so suppose you have a container like this. I know it looks kind of odd, but bear with me. Now, there's liquid here and here. I should probably draw it. Now, the input area here is 0.01 meters squared, and the force being applied onto this input area is 200 newtons. Now, if we do a quick calculation of what this would be with force over area, it would be 200 over 0.01, which gives us, so that this number is the pressure being applied. Now, this pressure, if we times it with this area, which is the output area, we get the force, because in the formula it is like this. So in order to get force, it is pressure times area. Now by timing these two values together, we get force, and the force is 20,000 newtons, which, fun fact, can lift an elephant. So what does Pascal's principle mean in daily life? Well, one of the most common application examples of Pascal principle is the hydraulic braking system used in many automobiles or cars. Every time you press the brakes, the Pascal principle is actually in action because in a brake, believe it or not, there's actually fluid in it. And by pressing on the brake, there's generates pressure and the car ends up stopping. Now there's also hydraulic lift, hydraulic jack, in the auto repair shops, and many places use Pascal principle. So thank you for watching.